Right, today we're starting 5.1. We're going to continue with our trig functions. We have trig identities here, so we're using our trig functions but in a different way than we have before. So we're going to be using these trig identities to kind of rearrange the trig function that it gives us. So these are going to be given to you on a test or quiz, so you don't have to memorize them. So what I would do is have them open next to you when you're doing the homework. That way you can kind of treat the homework as if you would a test or quiz. So have these with you while you do your homework. The first trig identities are reciprocal identities. So these we've seen before. We know them. Sine is the reciprocal of cosecant. So sine, it uses u here, but we could see u. We could see this as x or theta. It doesn't matter what variable it is, but sine is equal to 1 over cosecant. So these are all of our reciprocal identities. These should not be new. We know these. Next, we have our quotient identities. So tangent is equal to sine over cosine, and cotangent is equal to cosine over sine. And then we have our Pythagorean identities. So sine squared plus cosine squared is equal to 1. 1 plus tangent squared is equal to secant squared, and 1 plus cotangent squared is equal to cosecant squared. So anytime you see one of your trig functions squared, most likely you're going to use one of these Pythagorean identities. On the next page, we have some more identities. We don't use these as much, but on WebAssign, you could see, I think there's a question that'll say like sine of pi over 2 minus u, and then you would just type in cosine u.
Are we going to have to memorize this? Or?
No, these are given to you also. So we don't really use these as much, but you will see them on WebAssign, so you can practice them there. When you're typing in your trig functions on WebAssign, make sure you do it in all lowercase. So all lowercase. All right, so let's look at example 1. We're going to use identities to evaluate the function. So use the values secant u is equal to negative 3 over 2 and tangent u is greater than 0 to find the values of all 6 trig functions. So this type of problem we've seen before. In terms of x, y, and r, what is secant? Anybody remember?
Secant was y over r, right?
So secant goes with cosine.
Oh, it was x.
So it would be r over x.
So this would be r over x. Because remember, cosine deals with the x. So secant is r over x. So this, we have 3 over 2. Would the negative go with the r or with the x?
X.
How do we know that it goes with the x?
Because isn't the r the hypotenuse?
Because r is our hypotenuse and r is never negative. So that negative goes with the x. How can I find y?
Squared plus y squared is equal to r squared.
Awesome. X squared plus y squared equals r squared. So our Pythagorean theorem. So x is negative 2, so negative 2 squared plus y squared is equal to 3 squared. So 4 plus y squared is equal to 9. Subtract 4 on both sides. Y squared is equal to 5. So y is equal to the square root of 5. So I have to find all 6 trig functions. So let's start with sine. Sine u, yes.
So when it says that tangent is greater than 0,
I'm going to save that for the last step.
Okay.
So sine would be what over what? In terms of x, y, and r. It's y over r. So our y is square root 5, and our r was 3. That we had from up here. Next we have cosine u. Cosine would be x over r. So that would be negative 2 over 3.
Is U just like theta?
Yeah, u is theta. So it's the same thing as saying like cosine x or cosine theta. It doesn't matter what variable you use. They'll also use like cosine of the little fish type thing, which is alpha. So it's just a different variable, but it doesn't matter. Next we have tangent. Tangent is what over what? In terms of x, y, and r.
Or y.
Y over x. So y is square root 5. And what was x? Negative 2. And then we can just use our reciprocal identities and just flip them. So we're used to doing this. Cosecant u would be the reciprocal of sine, so we just flip sine. So this would be 3 over square root 5. But we have to rationalize. So multiply the top and the bottom by square root 5. So we get 3 square root 5 over 5. Next we have secant. Secant was given to us. It's negative 3 over 2. And then lastly we have cotangent. So cotangent is the reciprocal of tangent, so we just flip that. So it'd be negative 2 over square root 5. But we have to rationalize. So multiply the top and the bottom by square root 5. So negative 2 square root 5 over 5. And then last thing we want to do is check our signs of all of these. Make sure we're right with which ones are negative and which ones are positive. So we're going to use this tangent of u is greater than 0 to help us with that. So anybody remember our acronym that helps us with our signs? All students take calculus. So we have tangent is greater than 0. So which two quadrants can I cross out right away? The second and the fourth. Because if tangent's greater than 0, that means that it's positive. So it's either going to be in the all positive or in the tangent positive one. And then I also know that secant is negative, because that was given to us also. Secant goes with cosine, so cosine's negative. So which quadrant would I cancel out? The all one. So then I'm just left with quadrant 3. So what are my only two functions that have to be positive? Tangent and cotangent. So the only ones that are positive are tangent and cotangent. Yep, so we have to fix it. So that means sine has to be negative. Cosecant is also negative. Cosine and secant are negative, and then tangent has to be positive, and cotangent has to be positive. So super important that you always check your signs at the end. If you wanted to do it in the beginning, it kind of would have saved us time to fix it, because when we found y, we would know that this should be negative square root 5, which would have made our signs right to begin with, but you could always just do it at the end. All right, let's take a look at example 2. So here we're simplifying a trigonometric expression. So we're still using our trig identities here. Our goal is to simplify this. And when we simplify our trig functions, it'll help to think about it in like algebraic terms. So like if we thought that sine is x and cosine is y, so just as like replacing them with variables, I would have x times y squared minus x. So I just replaced sine with x and cosine with y, just to kind of help us see it in algebraic terms a little bit better. Do I have any common factors that I could take out here? An x. So here, what are my common factors? Sine. So I have a sine in both of these that I could take out. So I'm going to take out sine of x. And what am I left with when I take out sine of x from both of these? Cosine squared x minus 1. Perfect. Because I'm dividing this by sine of x and dividing this by sine of x. So I can't forget that 1 that I'm left with here. Any questions so far? All right. Now you see we have a cosine squared x. So we may have to use one of our Pythagorean identities. So the Pythagorean identity that involves cosine squared would be sine squared x plus cosine squared x is equal to 1.
Are you just gonna like move them around and stuff?
Mm-hmm. So can I make this equation here look like cosine squared x minus 1? How?
Subtract the 1 and subtract the sine.
I can subtract 1 on both sides and subtract sine squared x on both sides. So that moves my sine squared x to the other side. I'm left with cosine squared x minus 1. The 1's cancel, so it's equal to negative sine squared x. Because I subtracted the sine squared x on both sides. So I have cosine squared x minus 1 here, which looks exactly the same as this cosine squared x minus 1. So what can I replace cosine squared x minus 1 with? Negative sine squared x. So I have that sine x outside, and I'm replacing it with negative sine squared x. Replace the inside with this. So my answer here would be negative sine cubed x. And that's the answer. So 3 says that we have to factor each expression. So starting with A. So it may help to just replace our trig function with x and then kind of see if we know how to factor that. So I'm just going to replace secant with x. So I have x squared minus 1. How can I factor x squared minus 1? I'm not solving it, I'm just factoring it. So x is a perfect square and 1 is a perfect square. Yep, so this would be x plus 1 and x minus 1. Which I plugged x in for secant, so I'm just going to plug secant in for x now just to put it back. So I have secant theta plus 1 times secant theta minus 1. Now you don't have to replace it with x, but if it helps you see it a little bit better in algebraic terms, it may help to replace it with x, but you don't have to.
When I first looked at this one, I tried to use the Pythagorean identities. Can you do that? Are we going to get the same answer? Because I don't know like how to decide which one to use.
If it said simplify, Pythagorean identities would be what we used.
Okay.
But here it just says factor.
Alright. So factoring, you don't use the Pythagorean identities.
Right.
Okay.
We could, if we, you'll see, I think example 4 we do. but that's just to make it all in the same term. So,
Okay. But it's not like it wouldn't be the first step.
right.
Okay.
If we're simplifying, we would want to use our Pythagorean identities here. But we're just factoring. So that's our factors. So let's look at B. So I'm going to replace tangent just with x, kind of help us see it a little bit better. So I have 4x squared plus x minus 3. How could I factor this?
Multiply first and last time.
Multiply the first and the last. So 4 times negative 3 would be negative 12. And what are two factors of negative 12 that add to 1?
4 and negative
Plus 4 minus.
Positive 4, negative 3. So I would have x plus 4 and x minus 3. What do I have to do next?
Divide both by the 4.
Awesome. Since I started out by multiplying, I have to make sure I go back in and divide both of those by the 4. Simplify if you can. If you can't simplify, you move it up to the front. So 4 divided by 4 would be 1. So this is x plus 1. Can't simplify 3 over 4, so the 4 would become the coefficient to that x.
So the 4x minus 3.
4x minus 3. And then what's the last step that I have to do?
You have to solve for it?
I have to change x. So I
No.
put x in for tangent, so I just have to make sure I put tangent back in for x. So I have tangent theta plus 1 times 4 tangent theta minus 3. All right, example 4. So here it tells us to factor again, so we're doing the same thing we did last time. But we have two different trig functions here. So this would be like saying x squared minus y minus 3. Could I factor something like this? No, because I have x's and y's. I want them all to be the same trig function. So what do you think I should do here?
Find an identity.
I could use an identity. Which identity would I use? I need to manipulate my equation to make it all the same trig functions.
Would you use, I think with Pythagorean identities, which means the one plus b equals
Awesome. We like that one because we have cosecant, so that kind of gives us a hint that we are going to use an identity that has cosecant. And even better, it has cotangent in it, which our equation, the other trig function is cotangent. So that one would be perfect. So it's 1 plus cotangent squared x is equal to cosecant squared x. So I have cosecant squared that equals 1 plus cotangent squared. So I'm going to substitute this 1 plus cotangent squared in for cosecant squared. So 1 plus cotangent squared x minus cotangent x minus 3. Do I have any like terms that I can combine? 1 minus 3. So what's 1 minus 3? Negative 2. So I have cotangent squared x minus cotangent x minus 2. So if it helps us, we can think about it in terms of x. This would be x squared minus x minus 2. So what are two factors of negative 2 that add to negative 1? Negative 2 and positive 1. So this would be x minus 2 and x plus 1. And then what's my last step? Plug cotangent back in. So I have cotangent x minus 2 and cotangent x plus 1. So this is a case where we had to factor, but we had to use our identities first. Because if it gives us trig functions but asks us to factor, we want all of our trig functions to be the same. So we have to simplify. So sometimes when it gives us a whole bunch of different trig functions and we don't know where to start, it may help to turn everything into terms of sine and cosine. So I have sine t. How can I change cotangent to be in terms of sine or cosine? Just because it's a start. It's something to do. We want to make all of our trig functions in terms of sine and cosine to see if we can like combine anything together or cancel anything out.
Cotangent can be written as cosine over sine.
So cotangent can be written as cosine over sine. I'm going to use x instead of t here just so we don't get confused with the plus signs and the t's. So I have sine of x plus cosine x over sine x times cosine x. What can I do next? So our goal is to simplify, so we want to kind of condense it to be maybe like one term or as small as possible. I can't because I'm adding them, so they don't cancel.
Could we multiply the cosine x over sine x with cosine x?
Was that what you were going to say?
Yeah.
Yep, so we can multiply cosine x and cosine x. So I have sine x plus cosine squared x over sine x.
Could we turn sine x into sine x over 1 and then we can solve as fractions? Did you expense it?
We could do that. So Lily's saying that turns sine x into sine x over 1. And what should we do?
We can like condense it from there because then you can multiply sine x over 1 by sine x. That would be about the same denominator.
So Lily's saying we want to combine these, so we need a common denominator. So what I can do with my first fraction is multiply it by sine x over sine x. So on top, I have sine squared x over sine x. To get a common denominator, to see if I can combine them. Well, I know if I have a common denominator, I can combine them, but just to see where that would get. It helps me simplify. So now that I have a common denominator, I can add them together. So on top, I have sine squared x plus cosine squared x. And then on the bottom, what am I left with? Sine x. Can I simplify the top?
Yeah.
What's sine squared x plus cosine squared x?
1.
1. So that's one of my Pythagorean identities. Sine squared plus cosine squared is 1. So I have 1 over sine x. And what does 1 over sine x simplify to? Cosecant. So my answer is cosecant x. So I simplified this to cosecant